Hi, everybody, and thank you for joining. It would be a pleasure to know from where you are joining, so please let us know in the chats from where you're joining. Today's topic is about oil and lubrication in commercial refrigeration systems. And as you can see, I have John and Jörg joining us here today. John, would you please introduce yourself? Who are you? What are you doing?
Certainly, Jens. Hello, everybody. My name's John Broughton from Danfoss. I've been in the refrigeration business since I was a wee small boy, 16 years old, and done various roles within the refrigeration industry, and now work for Danfoss for quite some years. I now work in the global application team with a focus really on commercial refrigeration. So I spend a lot of time dealing with customers, working on site with breakdowns, etc., and then also quite a lot of training material as well. So hi to everybody, and as Jens said, please let us know from where you are, where you're watching us from, etc. We thrive on that sort of communication. So good to see everybody. So thanks, Jens.
And Jörg, who are you and what are you doing, please?
Well, yes, welcome from my side as well to everybody. I'm Jörg Saar is the full name. I'm as John in the global applications team of Danfoss, focusing on refrigeration or cooling, but quite a lot on refrigeration as well. As you probably can hear, I am German, sitting in Germany, not too far away from the French border right now. And looking forward to hear your questions as well. So if you have some questions, please feel free to throw them at us, and then we can discuss all that. But with that, then back to you, Jens.
Yeah, thank you. I'm Jens Andersen, and I've been with Danfoss for a million years. I think it's 43 years to be precise. I've been in different positions, working with drives and cooling and hydraulics for a short while. But the last something like 20 years, I've been working with digital communication in all different kinds of sizes and shapes. So, Jörg, the first question is from me to you. Why have we chosen this topic today about oil and lubrication?
Well, if I'm a bit negative, I could say because oil is annoying. No, it is not. We need the oil in the refrigeration system to lubricate the compressor, of course. But then we need to make sure that we do that in the right way. So compressors don't break, we get the oil back. We need to pay attention, what is the oil doing in the system, apart from lubricating the compressor. And that's all the stuff we're probably going to talk about today. Yeah.
And John, do you have any additions to this explanation?
I guess, Jens, to sort of mirror what Jörg is saying, as I said previously, I spend a lot of time on site with issues, let's say, with refrigeration equipment, and a lot of the time you'll go to a compressor and it's either got too much oil in or it's not got any in. So I class oil as the lifeblood of the compressor, lifeblood of the system. Without it, the compressor unfortunately is going to die. So it's a sort of pet topic of mine to make sure that we understand what the oil does, where it goes, why it goes there, and how we try and keep it in the compressor, basically. To throw a nice statistic out there, and I'd really welcome this from our audience. In years gone by, let's say, when we used to do the warranty returns here in the UK, about 20% of every compressor we got back had no oil in the sump. So that sort of taught me something, that this is something is going on. So basically to mirror what Jörg said, and it's the lifeblood of the machine. So very important.
Mm-hmm.
And you said, did you say 20% was missing oil?
Yeah, roughly 20% of all the compressors. where had no oil in the compressor.
Where did that oil go?
Generally, it was in the system somewhere. So generally, it gets pumped out by the action of the compressor, and it will be in the pipework. It will be in the evaporator. Or they've had maybe a refrigerant leak and they've lost some oil. Maybe they've not put the oil back in, or maybe the system's had very long pipe runs. So a certain amount of oil does get pumped out by the action of the compressor, but you need to make sure that you keep that level in the compressor, at the right place all of the time.
Maybe one remark regarding no oil in the compressor. And really just to mention that, of course, there are compressors, but there are compressors without oil on purpose, because those compressors are built in a way that they don't need oil. But that's only a special kind of compressor. For example, that Danfoss turbo core compressor, which is kind of a turbine, and that is on magnetic bearings, so the whole system has no oil whatsoever, because that compressor does not need oil. But sorry, sidekick, just to mention that most compressors, especially in refrigeration, have oil, whether those are screw compressors, scrolls, pistons, rotaries, whatever. These compressors are lubricated using oil. Let's call it oil. It's a lubricant, but to make it short, it's oil. And that's, as John said, sometimes it's going away. It's no longer in the compressor, and that's a problem for the compressor. And that's why it's so necessary to bring that back to the compressor during normal operation.
Right. And so the most natural thing would be to blame the compressor, that it's missing oil, or what?
Yes, that is of course a possible thing, but quite often you don't necessarily notice that there is no oil in the compressor. If you don't have an oil side glass in the compressor, you might only notice when the compressor failed, you take it out of the system and you realize all of a sudden there is no oil in the compressor. If you have an oil side glass in the compressor, you might have the possibility to see that the oil goes away and all of a sudden you don't see oil in the compressor anymore. It is very normal that every compressor, of course, is compressing refrigerant. That's its job. Yeah. But with that refrigerant, there's always a little bit of oil leaving the compressor. That's how it is. You cannot avoid that. So there's always a little bit of oil spill into the system. And that's why it's so necessary to get the oil back. If you don't get it back, it accumulates somewhere in the system, and then the compressor is empty. And as you said, the blame often goes to the compressor, not in the way that it puts oil into the system, but the compressor failed. But it failed because there was no lubrication. And then the question is, why not? Where is the oil? What happened? And how can I avoid that?
John?
Yeah, I'd say the same as Jörg. You have the operating condition of the compressor, whether it's scroll, recip, whatever. You will, by the action of the compressor, you will lose oil out of that machine. You have to get that oil back, and we can do that. You could fit an oil separator, for example, on the discharge line, and we recover the oil that's carried over by the action of the compressor. And then that oil is returned to the crankcase. That's one way of doing it. Obviously, there's a cost involved in there. You can also make sure that all the pipe sizing is correct, the velocity is correct. So in particular, the suction velocity coming back from the evaporator is high enough to entrain that oil back to the compressor. Good piping practice, for example, if you have a pipe lift on a system, make sure that you have risers within that so that we can increase the velocity and bring the oil back. There's a lot of things that we can do to maintain that, and that comes through education, experience, all of those things to do as much as we can to look after that oil. I'm always a great believer when you install a system and commission a system, don't just install it, turn it on and leave. Spend some time, and I know time is a challenge for everybody these days, on site, but just wait a little bit and just see how the oil level settles down, and then maybe after a day or two, I know this is a challenge, but physically come back and just make sure that we are maintaining an oil level within that compressor. There's other things like the operation of the expansion valve. If we flood that machine during startup, or we're returning liquid to that machine, that will carry over the oil as well. So everything has to be in balance, let's say, for that system to operate effectively. So there's many topics, I guess.
Yeah.
And maybe to mention that, just to give an idea how fast all of that can be. Let's say a compressor brings in 1 or 2% of its swept volume as oil. Only 1%, then the calculation is easy. So that means if you have 100 liters of refrigerant going through that compressor, then you have 1 liter of oil going through that compressor. Now, if you have a compressor that has 1.5 liters of oil, after 150 liters of refrigerant, that thing is empty, completely dry. So in that time where you shovel 150 liters of refrigerant through the compressor, you need to get the oil back from the system. And that means you don't have 3 days for that. It can be pretty fast. It's more than a few seconds, but you don't have hours often on smaller systems. It's sometimes only minutes when you need to have a return flow of oil before your compressor is empty.
Right. Actually, Jörg and John, we've got a question from the audience. Matayan, he is asking, how do we find the net charge or the quantity of oil for a parallel rack system? Can you explain? I mean, it has something to do with what you just said, I guess.
Yeah. If you want, John, or I can start as you wish.
Yeah, go, Jörg.
Well, if you have compressors in parallel, of course, every compressor brings its own oil charge. And then these oil charges the compressor oil charges are typically made for single compressor systems. So you have a compact system and one compressor, and then the oil only needs to feed into a smaller system and comes back. That's the approach, how much oil you find in a compressor. Now, if you put several compressors in parallel, you have a bit more oil, so you can have a bit larger system. But as soon as you have too much of pipe work, your oil charge is not enough. And how to do that, how to calculate how much oil you need, is, well, really look at the system and check whether you have oil traps somewhere, points where oil will be collected anyway. John has mentioned that already. You have pipes going upwards. You have these U-bend oil risers there. So you will collect some oil there. Do a rough calculation how much oil you will have there, and at least that amount needs to go into the system in addition. Then think about all the long pipes, how much oil you might have there. So it is a bit difficult to say per meter that much, because that depends on the pipe dimension as well. And it depends a bit on what type of heat exchanger you use, how much oil can be stored in the heat exchanger. But the bigger your pipe work and the bigger your system, the more you probably need to add oil so that you can fill all these points where oil will accumulate. You cannot avoid accumulation of oil somewhere, not completely.
Right. John, do you have anything to add?
I guess the only thing to add really, as Jörg said, if you've got a a pack or a rack with multiple compressors, normally you would have some form of oil recovery system on it. So you might have some oil separators per machine, or you might have one big oil separator on the common discharge line, for example. Then you might also have floats in the compressors. You'll have an oil reservoir, maybe. So there are various things that you can do and build into your system. With an oil reservoir, you would have an excess of oil, so you charge the oil reservoir to ensure that you always have enough oil to actually feed back to your machines. The calculation of that, yeah, it's not something that I would get involved in, to be honest. But as Jörg said, if you've got a smaller system, you're going to lose a certain amount of oil. If you've got a bigger system and longer pipe runs, bigger diameter, oil will, coat the inside of the pipes. So you will lose a certain amount. There are, I'm sure, calculations out there to work out the oil film on pipes and so on and so forth. I've seen something in the past. But yeah, it's just to sort of highlight, I guess, that oil is important. We do lose oil by the action of the machine. We need to make sure it comes back, and we need to make sure that we, regulate that as best as we can.
Just maybe, sorry, Jens, but John mentioned oil separators, and before I forget that, I would like to mention something about that. The oil separators, they are typically in the discharge line just close to the compressors, which makes a lot of sense, of course. The idea is that you separate most of that oil from the discharge line and bring it back to the compressor pretty fast again. But you never, ever get all the oil out of the discharge gas, even with an oil separator. So just to mention that, if you install an oil separator, be aware that over time, and that takes a bit longer then, but over time you fill oil traps in the system as well. It just takes a bit longer, and that's why it's so important what John mentioned before. If, especially on these larger systems, if you have them running, check later on again, because over time, let's say throughout a day or two, these oil traps will be filled, and then you need to check, do you still have enough oil in the compressor? Is your oil reservoir in the filter that you need to pre-fill, in the oil separator that you should pre-fill, is that enough to feed all these points where oil will be sitting in the system? An oil separator is a good device, but there is no oil separator that takes out 100% of the oil out of the gas. There's only a little bit left, and over time that wettens kind of the pipes from the inside with oil.
Right. We've got another question from Simpson Arifin. I don't know. Arifin? I don't know. It's how much oil escapes compressor's crankcase and circulating with the refrigerant throughout the system. And again, I think it is more or less relevant to where we are right now in the discussion. Jörg, you said something about, did you say?
So that there are, I mean, on average, as a very rough rule of thumb, you can assume 1 or 2% of the refrigerant flow through the compressor. As a rough shot, there are compressors which might feed out up to 5% of oil into the discharge line. Others have only 1 or 2%, but approximately like that. That's approximately the range, how much oil leaves the compressor.
Right.
I have a question actually for you, Jörg, I guess. Is there a difference between the oil carryover rate then between, let's say, scroll and a recip, or is that fairly similar? Or then we could maybe talk about, and I know we're talking about commercial, but if you talk about an industrial compressor, for example, a screw, has that got a higher carryover rate?
Well, for recips, now, as far as I know, right, and just the compressors that I know, so you might find a compressor that has a different oil spill rate, but roughly they are in the same ballpark. Piston and scroll compressors, rough shot, same ballpark. Those for commercial refrigeration systems and medium-sized air conditioning systems. If we go to really large compressors and take a screw compressor, a screw would put out quite a lot of oil. And that's why most screw manufacturers have an oil separator integrated into the compressor. And with that oil separator, they come down to the oil rate mentioned before, or even lower than that, because of that integrated oil separator. The screw needs a lot of oil to tighten the compression space between the screws. Oil is used for that. That's why it would throw out a lot of oil, and that's why compressor internally there's a high flow of oil. But scrolls, recips, roughly, rough shot, same ballpark. Between 1% and 5%, in the range of 2 to 5, something like that. That's an average shot.
Perfect. Thank you, Jörg.
And just to mention that, we talk, John, you said that as well, you focus on commercial refrigeration. That's what we talk about here. So if you say, yeah, but in an ammonia system, industrial refrigeration, I have these oil valves on evaporators, right? Yes, that's correct. That's not what we focus on here. So we really try to focus that on commercial refrigeration systems.
Right. Matayan Murugan has a question about oil pressure, but let me just read aloud what he is asking. How can we differentiate high oil pressure and low oil pressure in a system? You are thinking aloud.
Yeah, and I'm trying to grip the meaning that a bit. There are two ideas I have now, Matayan, and I don't really know whether my answers fit to what you think about. But of course, you have an oil pressure that can be on the discharge pressure, so condensing pressure, because the oil goes out in the discharge gas. If you have now an oil separator that is on discharge pressure, then you have oil sitting there on discharge pressure. And then you might have an oil pressure level that is on suction pressure, because the oil is sitting in the crankshaft, not in the crankshaft, in the crankcase, and that's where you have the suction pressure. And then you have your difference between high pressure and low pressure, and you can use that difference to transport the oil from the collection part of your oil separator. That would be one potential part of the answer. The other one might be that there are different compressor designs. Let's take a scroll compressor. There are scroll compressors which are designed in a way that your oil sump is on the suction side. And then you have oil sitting in the compressor on the suction side with suction pressure. And then there are compressor designs where the oil sump is sitting on discharge pressure. So the whole oil reservoir in the compressor is on discharge pressure. It's just a different design principle of compressors. Maybe that's what you've been thinking about. And that's why I'm not really sure whether I have answered your question or not. I'm sorry.
The other option, Jörg, might be regarding if it was a semi-hermetic, for example, which had an oil pump. So a mechanical oil pump actually on the compressor itself.
Yeah.
And in that case, then you would have a oil pressure differential switch that would basically say, yes, I've got enough oil pressure and we can continue to run, or no, I've not got enough oil pressure, and it would stop the machine. And that is a setting within that oil differential pressure switch. So that works off your pump pressure compared to suction normally. So that is one option. I just to sort of to discuss really regarding oil pressure switches. Lovely. The only issue that I sometimes come across with them on machines is that as you generate your oil pressure, you can, you know, the switch will say, yeah, I'm okay, I've got enough oil pressure, that's fine. Then you might get a situation where you don't have quite enough oil pressure because there's not really enough oil in the crankcase, and it will then trip and start the timer going. And then just as the timer is about to expire and shut the system down, you get a little bit of oil pressure, and it takes the heater out of circuit, and you get this sort of row effect where you've almost got enough oil pressure but not quite enough oil pressure. So you know, good, but they are not let's say foolproof. But how can you differentiate between high oil pressure and low oil pressure? If you've got a mechanical pump, then you'd have an oil pressure switch on there. That is the only way, as far as I know. A lot of all of the compressors we manufacture as Danfoss have a venturi at the bottom of the crankshaft, which basically draws the oil up through the drillings within the crankcase. So if you have oil in the crankcase, then you would pull the oil up through the drillings in the crankcase up to the bearing surfaces, etc. So that's another sort of take on the question, I guess.
Another question, and this is for you, Jörg. I think Abhijit Singh here is asking, is it true that type of oil which is used in system depends on the refrigerant used in the system?
Yes, that is very true. So there are different oils, and that's why at the beginning I said let's call them oils, but it is a lubrication material, which in short is oil. Yeah, but they are chemically quite different, and you need to adapt this oil to the refrigerant you are using, because it is necessary that you can mix oil and refrigerant in certain combinations at certain temperature and pressure levels to make sure that the oil really runs through the system and can come back as you want it to come back. If you don't have that mixability, things get more complicated. You can do that and so on, but it is easier when you have a good mixability, and that's why you adapt an oil to the refrigerants you use. That's one point. The next point is you adapt an oil as well to the compressor type you use, because you might have different material stresses in the bearings and so on, and then the oil needs to be made for that as well. Now, if you wonder how you can know which oil you can use for which compressor, well, at least for Danfoss compressors, there is a list of oils which are used in which type of compressor. And if you give me 1 second, then I can try at least to share that one. I think I found it. Here we go. No, we don't go. Oh, why can I not share my screen now? Here we go. I hope you can see a PDF file now. And if I scroll up, it says overview of oil types. Can you see that? Jens, John, can you guys see that?
Yes, yep, I can see that.
Okay, all right. So that's as it says, an overview of the oil types which are used for the different compressors. And just let's take the first few compressors. There is the MTZ compressor, MT compressor. So one is for R22 that uses a mineral oil, and for other refrigerants like 44, 45, 449, 452A and so on, there is in polyester. And then you see the name of the refrigerant, which has to do with viscosity and stuff like that. But as you can see here, there are different refrigerants listed for the different oils, or the other way around, different oils for different refrigerants and different compressor types, depending on is that a scroll or a piston. So to make it short, yes, the oil needs to fit to the refrigerant you are using in the compressor.
Yeah. Yeah.
Oh, and of course you can download that from Danfoss, that file here, and we can provide a link where you can find that.
Great. Yes, perfect. We have another question from Harry Prasad. What happens when the compressor is overcharged or charged with excess oil?
That's an interesting question, I guess. A lot of that will depend on what type of compressor it is. If it is a small fractional compressor, you've not got so much shell volume there, which is where the oil would be between the shell and the workings of the compressor, if you like. So you could get to a stage where you've got more oil than normal, which would be absolutely fine. But if you get too much oil, then that will basically get pulled into the suction tube, the suction galleries of the machine, and then your compressor will try and compress oil. And as I always say in many trainings, the compressor is a vapor pump. It's not a liquid pump of any form, whether that's oil, refrigerant, water, things like that. So if you get to that stage, then you will start to pump oil, and you will unfortunately damage your machine. So a lot depends on the type of compressor, whether it's a fractional compressor. If it's a larger compressor, then you've got a larger shell volume. And, for some of the MTZs and things, you would have to have a lot of oil in there to actually fill it up to a point where it spills over and gets into the suction side of the machine. But obviously it's possible. So I don't know what that limit would be, but on some of the larger machines, that's quite a bit of oil.
Yeah, of course, when you start a compressor, let's say you have the system standing throughout the weekend and a lot of the refrigerant goes into the oil. Now you start the compressor, it boils out of the oil and it might generate foam. And the more oil you have then, the higher that starting level is. And then you have the machine filled with foam, with oil foam, and that will be sucked into the compressor. And that's another possibility, that too much oil can kill a compressor. But as you said, John, on larger machines, you need to put quite a bit into that. Yeah.
Mm-hmm. Yeah, and I guess, Jörg, it's worth mentioning, to avoid that scenario of refrigerant dissolving in the oil, and when you start up the machine, the suction pressure falls, so that refrigerant tries to boil off rapidly within the oil, and you get that foam scenario. Use a crankcase heater in the compressor, and make sure that compressor is nice and warm. We have many types of crankcase heater. We've got the belt type heater, we've got the insertion type heater for the MTs that goes in a little pocket in the sump. Please never assume that the crankcase heater that is fitted to a machine is sufficient for the application. For example, if you put a machine on top of a roof that's in a prevailing wind in the middle of winter, a tiny crankcase heater will never keep that shell nice and warm. So maybe put an additional heater on there. If it's a suction gas cooled machine, you can insulate the machine itself, put a jacket on it, keep it nice and warm, and then you will avoid that scenario, because that really is one way to kill the machine very, very quickly. If you if that oil becomes, let's say, not oil and a refrigerant oil mix, it will not lubricate the bearings. And you can get a situation where the refrigerant that's dissolved in the oil, when you start that machine, it basically evaporates like crazy, and it will destroy the bearing metal on the on the moving parts itself. And you can see that because the white metal of the bearings actually starts to come away. So it's a very, very quick way to kill a machine. So yeah, always try and keep your machine warm. As a very old colleague of mine said to me once, if you need a coat, so does the compressor.
Yeah. Another question, actually also pretty relevant to what you just said, John, code or not code. It's Abhijit Sinhe. What is the difference in oil circulation in high, medium, low, and ultra low temperature refrigeration systems? I guess, yeah.
Jörg, I'll let you take that one because I think you have more experience on, let's say, ultra low, but the situation is the same, I guess.
Yeah, and basically, there's not too much difference. Of course, the oil circulation depends on pressure ratio, pressure differences for the compressor, but in general, you don't have a major difference between these systems. What's getting more and more complicated is the colder you are, and that's why we come especially to ultra low systems, ultra low temperature systems. The colder you are, the more, how to call that, sticky, like honey, your oil gets, and that's then sitting in the evaporator, holding tight to the evaporator and saying, no, I don't go out here. I'm sitting here. I'm sticking here, and that's why you have a bit of a challenge, and that's where it's really important to have the right oil. So ultra low systems is a challenge regarding the oil, that you have an oil that is really still able to flow at these ultra low temperatures. But apart from that, I don't really see major differences between the oil circulation rate. It can change. It can have, let's say, 2% at medium temperature and maybe 5% at high temperature or at low temperature, depending on the pressure ratios. But in general, you remain in that area. That's my experience, at least.
Yeah, I would say the same thing, Jörg. I think it's what I generally say when I do training is that the lower evaporating temperature you go, the more important oil velocity becomes, or suction velocity, refrigerant velocity within your pipes becomes, and good piping design becomes. So if you're in evaporating -30, for example, -28, -30 for a deep freeze room at -22, then that is incredibly important to get your velocity right in your suction line. Make sure your pipes slow back to your machine, all the general things that we should be doing anyway. If you're evaporating at -5, of course it's still important, but as Jörg said with his sticky oil, I like that, that will leave the evaporator far easier at -5 than it will at -30. So,
Yeah, put honey in the refrigerator and you see what happens to an oil that you put to ultra low temperatures. That's really what happens.
Yeah.
It gets that sticky.
Yeah.
Honey and oil, yeah. Good thing. Another question, Mika James is asking regarding oil level controls. Is it an issue if the oil is not at a stable level in the sight glass? I guess it's the oil level sight glass.
Well, as long as the oil level fluctuates between acceptable, what's wrong today? It's not that difficult, that word. Acceptable limits, then a fluctuation is okay, and can happen if you have multiple evaporators, you switch evaporators on and off, or if you have multiple compressors and stuff like that. And acceptable levels, of course, depends on what the compressor manufacturer is saying. So, but usually the acceptable level is 1/4 and 3/4 of the oil side glass. Sometimes it's going down to the lowest level of the oil side glass, depends on the compressor manufacturer. But if you sometimes have an oil side glass that is completely overfilled, where you don't see the oil level, and 2 minutes later you don't see the oil level because it's gone down so much and there is no oil visible anymore, that's not okay.
Yeah.
Great. Next question. James Steiger has a question. Sorry. how does a low superheat close to liquid flooding affect oil levels within the compressor?
I'll probably take that one, Jens, and that sort of follows on a bit from what Jörg said a minute ago. If your oil level in your machine disappears very rapidly, then generally I would say you're getting liquid back to the machine and the oil is being diluted by refrigerant. So if you have a low superheat close to liquid flooding, you're getting liquid back to your machine. That will increase the oil carryover rate within that machine, definitely. Things also to be aware of with that, as we said, if you dilute the oil, the oil itself will lose its lubricity, and then you start and damage your bearing surfaces in your machine. So it has a twofold situation. One, you start and damage the bearing surfaces. Two, you will increase your oil carryover rate, and you will see that oil level in your machine fluctuating greatly. So yeah, always best not to have liquid back to the machine.
Yeah, sure. Fabian Moss has a question here. What happens if the fill oil does not match the specifications of the plan? I guess it's about mismatch. Yeah, maybe. Yeah.
Well, there's a wide range of what can happen, from nothing when you are lucky to your compressor breaks pretty fast. That's really the range you have. In general, please refill the oil that is specified by the compressor manufacturer. The reason is, as mentioned before, well, it is selected for this compressor, for the loads, for the mechanical loads of that compressor, for the mixability with the refrigerant the compressor is approved for. And in that oil that is specified by the compressor manufacturer, of course, all these evaluations like mixability, viscosability, lubrication, and so on goes in. You might have additives in the oil which are good for whatever kind of reason in the compressor, which are needed. And if you put in another oil, then all this might not fit. And in worst case, the oil cannot, how to mention that, cannot carry the load that comes to the bearing. So the oil will try to do its best to do lubrication, but the load is so high that the oil simply cannot do it and is kind of squeezed away. And then there is no lubrication. You get mechanical friction in the compressor. That's it for the compressor. So that can happen as well. That means there is no black and white answer to this one. There is a big gray bunch, but it's the more your fill oil goes away from the specification of the original oil, the more you go into the not good area.
In the dark area.
Yeah.
We have a question from Abhijit Sinhe. The difference between BSE32 and RL68 oil. And John,
I have no clue. I'm sorry.
Yeah, I'll take that one, Jens. This goes back really to what Jörg said a minute ago. With our Danfoss hat on, as I always say, we have a Danfoss compressor. We know what oil goes in that machine. Now, I know what RL68 is. It's a synthetic polyester. I know that. I don't know what the other oil is, and I couldn't say whether you can use one oil or another oil. All I can say from a Danfoss point of view is if we state a particular oil on the data plate of a compressor, that's the oil that you need to use in that machine. And that's the end of the discussion at the end of the day. When I mentioned the data plate on the compressor, always, if you're going to refill a compressor with oil or top up a compressor with oil, always check the data plate on the compressor, because that will tell you exactly what oil you need to put into that machine. Jörg put up the PDF sheet before, which was overview of oil types. As soon as we print something like that, it becomes out of date. So good document to have in the service van as a backup, but always check the details on the data plate of the compressor, and only put the oil in that is on that data plate.
Abhijit is asking again a question: how to choose the oil return line size, the diameter, and what happens if it's oversized? I guess it's speed or velocity. John, is that one for you?
That's a good question, Jens, and I might pass it over to Jörg, because if we're talking oil return line from the oil separator, for example, that could be 1/4 inch, could be 3/8, because you're basically pushing the oil back to the crankcase via discharge pressure, because in your oil separator you have a float with a needle valve on it, and basically when that level gets to a certain level, the float lifts, and any oil that's in there is pushed down and back into the crankcase via discharge pressure. So normally it's 3/8, somewhere around there. If you increased it, then you have the possibility you don't want to get discharge pressure in your crankcase. I was always taught that it was 1/4, 3/8 was plenty big enough. If you had anything bigger, then as the oil goes into that pipe, maybe it doesn't become a full bore of oil, and you've got oil, let's say halfway, and then you've got a space where your discharge pressure could actually get into your crankcase. So that would be my answer. But Jörg, if you've got any further experience on that, welcome it.
Agree for sure to what you said. Yes, the only thing I might add is too big. I mean, of course, yeah, you need to pay attention that you don't make the pipe that big and you cannot fill it. Or if you fill it completely with oil, well, then you have enough oil available so that you don't get any gas into that line, as John explained, when the oil needle opens up. But too big only means it flows very slow, which is usually not a big deal. Too small means that your oil might get too fast in that line. So do a rough shot calculation and say, okay, in the worst case, I have approximately 5% of my refrigerant flow as oil flow. And then you can calculate these 5% means how many liters per minute or per second. And then you calculate whether your oil line is big enough to carry that amount of oil with less than 1 to 1.5 meters of oil velocity, 1 to 1.5 meters per second. If you are below that, you should be fine.
Good point.
Varun Av has a question. If there's oil accumulated in the accumulator, what would you suggest to get rid of that oil from the accumulator? And my guess is it's the suction line accumulator. John, you're nodding.
Yep. In a suction accumulator that you put in the suction line close to the compressor, the reason we put that suction accumulator in there is to prevent liquid entering the crankcase. And basically you have a tube in your suction accumulator, so the liquid comes hopefully not liquid, but the suction vapor comes in, and then you have a tube that basically goes out again. And at the very bottom of that, let's say U-tube, there's a very small hole, and that hole there is to basically entrain any oil that is in the bottom of your suction accumulator into that suction gas that's being drawn back to the machine. It's a very small hole, and that just entrains a little bit of oil at a time to bring it back. So you don't store oil forever in your suction accumulator. It is actually taken back to the machine over a period of time by this very small hole in the bottom of that pipe. So hope that answers that one.
Yeah, and if you don't have that, then check whether your suction accumulator is connected the right way, because it needs to suck out on the right pipe to be able to transport that oil out as well.
That's a good point, Jörg. Yeah, good point.
Yeah. Another question also from Abhijit, nomenclature of refrigeration oils. What does the numbers really mean?
Oh, I'm a bit reluctant to say that as a general statement, because every oil manufacturer, every compressor manufacturer might use a different naming and nomenclature. But quite often you have some relation to the viscosity of the oil. That's very often the case, but I'm really want to stress that I'm not saying this is in general for every name of an oil. It's just that you quite often have a relation to the viscosity of the oil measured in whatever number, centistokes or whatever.
Yeah, I guess it also depends on the what if it's a DIN or if it's a ASHRAE standard or whatever it's up against. So yeah, yes. So
yeah.
We have another question from Fabian Moth. It's a good one in a sense. What time is it a year for oil changing in the compressor? What time per year is it that you would change oil?
Sorry, I wanted to say I would prefer spring and fall, because winter is too cold out there and summer it's too hot when you're standing on the roof. But that was not what. Sorry. Well, many systems you don't need to change the oil, and especially in commercial systems, the idea is that you don't change oil. So the oil charge is in the system, it stays there, everything is fine. Of course, if you have leaks or if you have a burnt motor and all of that, the whole thing changes. But in smaller, medium-sized commercial systems, there's typically no oil change, no regular oil change. Larger systems, that might be a different thing, but that comes then from compressor specifications and so on.
Yeah, it's not a combustion engine, right?
Exactly. The only thing I can add to Jörg's comment, and this goes back to when I was an apprentice, which was many years ago nowadays, we always generally did the strip down of larger industrial machines in a period of time, and it was normally winter. So we got that machine ready for the summer. So during the hot period, that machine had to work very, very hard with high head pressure, high discharge temperature, things like that. So we generally always did the oil change and any sort of maintenance on the machine in the winter, get it ready for the summer again. But that was, large industrial type machines. So a little bit different to the commercial world that we inhabit these days.
Yeah. We have another question from Mohammed Abdul Sami. How much moisture can a refrigerant, or how does the moisture impact the refrigerant circuit and compressor and lubrication of? I guess it's about the moisture in the oil, or well, in both oil and refrigerant, I guess.
Well, let's put it very hard. If you have that much moisture in a refrigerant circuit that it dilutes the oil, you have a major problem. Moisture levels in a refrigerant circuit have to be, due to other reasons, due to chemical reasons, that low that they make no difference whatsoever regarding lubrication capabilities of the oil. You need to have a very low moisture level in a refrigeration system, or chemical processes will start which generate acids and stuff like that. So that's why your moisture level needs to be low in the refrigeration system. And that is far, far below a level that you have liquid water, which could dilute the oil. If you have liquid water in the refrigeration system, something else is totally wrong.
Yeah. I've got a slide, Jörg, that I'll just share and put on the screen, which basically shows the two sides to having too high moisture content. And this one is hopefully going up now. So you can see on the left-hand side there, you've got basically copper plating. So that moisture in the system is basically causing a chemical reaction and taking the copper ions from the tubing and putting it onto the hot parts of the compressor motor and the motion work itself. So you can see here on the bearing journals, we've got copper plating on the gudgeon pin, or the piston pin as it's called in the States. We've got copper plating, and again on the valve plates. And then on the right-hand side here, we've had a compressor burnout, which has been caused by acid. So the acid has attacked the varnish on the windings and has caused a dead short on the motor. So as Jörg said, we don't want moisture in a system. And, you know, I've actually somewhere not accessible, but I've got pictures of a compressor that we inspected some years ago, and it was rusty inside. There was physical rust on the inside of the shell. So there was a lot of moisture in that system. So yeah, just to show that.
Great. Another question, John Notario. What can I do if the oil level on the side glass of a compressor will be continuously low?
Recharge oil, or
Yeah.
put additional oil in. Really, very, very simply, there is probably somewhere a place where the oil has gone and where the oil is sitting now. It's constantly being replaced there in that area. But let's take a U-trap. The U-trap was empty, and now there is sitting some oil in the U-trap, and there's new oil coming. Some existing oil from the U-trap is going back to the compressor. So there is an oil flow in your system, but that oil in the U-trap is no longer in your compressor. You miss that amount of oil. So if it's constantly low on the same level, if it's not constantly going down, but if it's constantly low on the same level, oil is sitting somewhere else, and you need to refill, or you need to add oil. That would be my approach here. John, what do you think?
Yeah, I would say the same thing. Find out why. If you have topped the system up with oil and you're not getting that oil level, staying stable in the machine, then yeah, I would look at pipework design, velocity, obvious oil traps. If you have any vertical risers, for example, things like that in the system, look at the pipe length. I can share another slide here a second. We've not got this. We have this in a infographic that I guess we can put a link up to maybe now or later on. But basically, these are the sort of velocities that you should be looking at on a refrigeration system, whether it's a horizontal, vertical section, etc. And I've got fractional horsepower down there, or greater than a horsepower up here, and you can see the distances and these U-traps or goosenecks, they're called various things. And basically what we have there, we have a vertical lift coming back to the machine from our evaporator, and if we have a distance greater than 4 meters, put this U-trap or swan neck, and basically what that does is it pulls the oil up to there, it collects in this U-trap, and then as the refrigerant is going through with the right velocity, it entrains a little bit of oil every time, and it will eventually pump it up and get it back to the machine. So yeah, for me, I would be starting to look at pipework design, vertical lifts, things like that as well, would be my answer.
Great. I think, John, maybe you have already answered the question, kind of at least. The next question from Omar Henry. Does the size of the oil riser on an individual circuit in supermarket refrigeration rack system affect oil return?
Yeah, I guess that is the. I'll just put that slide back up. But hopefully I should put that slide back up. There we go. So yeah, I mean, basically the risers, particularly in supermarket, work. We've got very long pipe runs from the display cases back to the pack or rack. So that is incredibly important. We get the right velocity, the right pipework size, and ensure that we do good piping design and using oil traps and swan necks and U traps, etc., so that we are getting that oil back. Because if you think of a supermarket installation, normally you have the display cases on the shop floor. Normally the pipes go vertically up onto a cable tray that goes across basically the top of the store and then away to the pack and rack location. So you've got this perfect sort of, if you can see my hands, we go from the display case here, the pipes normally go up along the top of the store and then possibly back down to ground level again to where the rack is. So we've got this perfect oil trap scenario, and that velocity and the good pipework design of those risers is incredibly important. So in an answer, yes.
Yeah. We got another question from James Steiger. This is quite interesting question, actually. I don't know if you can answer this. Would an oil optical level sensor know the difference between oil and liquid refrigerant?
I don't know that. Do you know, John? Because
I don't know that, but I know in other work I've done for Danfoss, I've worked with optical sensors, and in general they know the difference, but it does depend how much foaming you get as to the accuracy of that. So bit difficult to answer because I've seen it both ways. I've seen them know the difference between oil and liquid, but then if you have a foam that's quite dense, then I've also seen them register that as a level as well. So a bit of a difficult discussion, and honestly I don't know the perfect answer. I know, from years ago when the optical sensors came onto the market, there was some worked, some didn't. They were a bit temperamental. I'm sure things have got a lot better, but yeah, not had that much experience, so difficult to sort of comment further.
Yeah. Another question from John Notario. What is the possible cause of bad odor from compressor oil? Why does it smell?
If you want, I can start, John. I have 2 or 3 ideas.
Yeah, go.
One is it's not the right oil. I mean, the crazy things happen out there, but maybe somebody has put salad oil into your compressor, which cannot handle the refrigerant and whatever, and that started whatever kind of crazy chemical reaction. So let's go away a bit from these total crazy things, but go to the refrigerant oil, and then you might have humidity and maybe oxygen, because there was still remaining air in the system. The system was not properly evacuated and there was still a lot of air there, or you have a very low suction pressure somewhere below ambient pressure, which takes in air. Then you can get chemical reactions there as well with the water and the air. And I would never exclude that this generates a strange smell. Third idea, but then the system should not work anymore, usually not. Your motor is burned, and that smells quite a bit.
Yeah, that's I would sort of say exactly the same thing, Jörg. Oil smells of oil, and I guess we all know what is a good smell and what is a bad smell. Again, it also depends on the refrigerant. Generally nowadays the refrigerants don't, we're not talking sulfur dioxide and things like that, which you certainly know about that one for sure. I would have said, yeah, mainly it's going to be a electrical problem, a burnout scenario, and if you smell that as an apprentice, or nowadays you never forget that particular smell. I've just put a slide up, hopefully, on the screen, which is and I don't know why it's not. There we go. that is a real burnout, and I don't know what the hell they did to that machine, but if you smelt the refrigerant from that, wow, that would make you probably fall over. So yeah, I think the only sort of comment you could say is that if it smells that bad, then you've got acid in there that is generating that bad smell.
Yeah.
We've got another question here on the late hours. It's Johannes Marcosi who's asking, do we have different oils for compressors when moisture in the system contaminates the oil? Yeah.
So you mean that if you have a lot of moisture in the system, you use a different oil which can handle the moisture in a better way?
I guess
if this is the meaning of the question, I don't know, but if this is the meaning of the question, no, we don't. That's not the approach. The approach is you use the oil that is specified, and then you make sure there is not a lot of moisture in the refrigeration system. And you do that by evacuating in a good way, by making sure that you don't leave pipes open long, that you don't leave oils open to the ambient air, because there are oils which grab humidity from the ambient air. And then you have to, of course, install a filter dryer in a refrigeration system. And whenever you open a refrigeration system, change that filter dryer.
Yeah.
Because that one takes the humidity out, that filter dryer.
Yeah, that's very good point, Jörg. And as you said, different oils will attract moisture. And thinking of the polyester, for example, they will pull moisture from anywhere, even to the point that if you use or open a can of polyester to top up a compressor, ideally you should then throw that away. You should not leave that in the van for another 3-4 months time, because you've got too much moisture in that oil itself. So be very careful of using half full cartons of oil that you've had in the service van for a while, because that oil can contain so much moisture. So yeah, just be careful of that.
Yeah. Another question, that's Dwayne Duxilly. Other than POE oils, what new oil is Danfoss introducing on the market? Well, I guess.
Well, maybe I can share my screen again and go back to that oil list here. Danfoss, of course, is not producing oil. Danfoss buys oil from manufacturers who produce oils for refrigeration circuits, and they produce them according to Danfoss specifications. We work with them to develop an oil specifically for a certain compressor range. Yes. And then there is the polyol ester, and you find those for several compressors. There is as well an oil type, a general oil type, which is this polyvinyl ether. But that's kind of only a family of oils, right? That's a bit like refrigerant families. When you say, well, there is a refrigerant family, hydrofluorocarbons, HFCs. That's a whole family. That's not a specific refrigerant. That's a whole family. And the same is with polyvinyl ether or polyol esters, because as you can see behind each of them, there are different numbers, and that means there is a different oil for that with a different oil specification. But those are the two types that are used for Danfoss compressors. What's to come maybe in 5 years, when we might talk about new refrigerants, other refrigerants, well, we need to look which oil we need then for those compressors. But that's what we look at now.
Grant. Yeah, Abhijit has another question. What care to take while storing the refrigeration oil?
No.
Yeah, go, John.
Yeah, I guess that comes back to my previous comment, Jens, is that if you're storing an oil, it very much depends on the oil type. Obviously keep it in its purpose-made container that the oil came in from the manufacturer. Keep it clean from the extremes of temperatures, and if it is a mineral oil, for example, it will keep a lot longer in the service van than a polyester, because it will not absorb moisture it will absorb moisture every time you take the lid off, but it will not absorb as much moisture as a polyester, for example. So and if they have a use by date, obviously don't keep it in the service van for 4 years, because that will not be much good, but really follow the recommendations from the manufacturer of the oil. Is the main thing that I would say. We're putting oil into that compressor to do a job, and that job is to lubricate that compressor. If there's any foreign debris in it, too much moisture, things like that, you're actually going to do more harm than good. So treat it like, as I call it, the lifeblood of the compressor.
With respect. Yeah.
Yes. Yeah. Exactly.
John is asking. Will compressor oil become acidic because of moisture?
They can, yes. And well, there's a bit of chemistry behind that, which reactions you have. But please have in mind that in a compressor system, the highest temperature is at the discharge valve of the compressor. That can easily go a good deal above 100 degrees Celsius. So that's where you have water, you have maybe copper there, you might have something else there. The copper might act as a catalyst, which enables certain chemical reactions. The high temperatures make the reactions more probable. Then you have maybe fluor from the refrigerant, or some other chemicals that can be split up from the oil itself, and all that can recombine into an acid. So the short answer is, yeah, acid or moisture helps a lot to generate acid in a refrigeration system. That's why it's so necessary to have a filter dryer to reduce the moisture level.
We have a kind of a follow-up from Sam Brewer on this. What is the best micron level on pulling a vacuum to try to ensure moisture removal from POE oil?
And John, you can add to that. But one general comment: if you have a lot of moisture in the oil, that's very difficult to vacuum that out. It takes a long time to vacuum moisture out of the oil. If you have a lot of moisture in the oil, then the best is either put a filter dryer in, change it after 2 or 3 days again, or best is really, if you know there is a lot of moisture, a very extremely high level, change the oil and put dry oil in. But the vacuum is really not there to dry out wet oil. It's there to make sure that you have taken the air out of the system and that you don't have any remaining water droplets somewhere in the pipework. But even that is difficult to evaporate completely.
Yeah, I mean, I would say exactly the same thing, Jörg. I mean, general sort of micron level, we're talking about 500 micron, which is, 29.9 inches of mercury, blah, blah, blah. But yeah, totally agree. If you've got moisture in the oil, very, very hard to get rid of. And the other challenge is if you have a low ambient temperature, it will take a lot longer to pull that vacuum because it won't give up the moisture as easily. If it's 45 degrees ambient, then the system will give up the moisture much more easily. But if you've got a low ambient and you're trying to pull a vacuum and the system's very wet, then it's going to take an awfully long time. And, we all know the the correct way to do a vacuum. Triple vac, things like that. So pull a vacuum, break the vacuum with dry nitrogen, scavenge the system round and pull it out and try and do that 3 times. That's one way. But if you've got a lot of moisture in your polyester, vacuuming alone, you will struggle to actually pull it out. So as Jörg said, literally just change the oil. It would be far easier.
Another question, and now I'm in trouble with the name. Nilum Padipa Wikamangasinke or something like that. Why does oil color change? I guess there are quite a few answers to that one.
There are 2 reasons. One, you might have debris, kind of small metal particles maybe in the oil, which come from wear. If you have a high compressor wear, you might have very tiny particles which float in the oil, which color the oil. That's one reason. The other reason is the chemical reaction. So you might have humidity in the oil. The oil is getting too hot in the discharge, on the discharge valve, whilst the refrigerant is compressed, and that kind of burns the oil, and then you discolor the oil.
We have another question from Abhijit. I don't know if we can answer that one because it's well. Let's take the question and see if we can answer that. When to change the vacuum pump oil? Can we use compressor oil for vacuum pumps?
In a word, no. It has to be a proper oil for a vacuum pump, and I'm just looking on some notes that because we don't make vacuum pumps generally. I'm just putting what I've got here. See if I've got anything. Basically, what I've got in my notes is change the oil frequently during evacuation. Moisture contaminates the oil and results in a poor lubrication of your pump. So when if I think back to my days as a service engineer, we generally change the oil in the pump after every job. Some say that's excessive. Some people may not change the oil for 6 months, but we had quite a strict service manager, and we had a rule: we always change the oil in the vac pump after every job where we use the pump. But yeah, you have to use proper vacuum pump. You cannot use compressor oil. Totally different things.
Abhijit is also asking, is it necessary to heat the oil while vacuuming the system?
That sort of comes back to what I said earlier, Jens, is that the higher the ambient temperature, then the more the system will give up the moisture easier. And that comes down to obviously the boiling point of the water, of the moisture. I've never known anybody heat a compressor crankcase to give up the moisture. I think you'd have to get it pretty warm. So yeah, don't know. It's not something that I've ever had to practice.
Yeah. Rafi Hashimi, he is asking actually a question I was thinking of also. How would I know during operation that the oil has moisture?
I guess that question comes to during operation of the refrigeration system. So whilst the refrigeration system is running, how do you know that there is too much moisture in the oil? If that is the question, that's reasonably simple, because the moisture level in the oil and in the refrigerant is approximately the same. The moisture distributes kind of in the system because you shovel the oil and the refrigerant around in the system all the time. And then a side class with indicator helps. So if you have a side class in the system with one of these indicators, for the Danfoss ones, for example, from green to yellow, then as long as it's green, fine. If it's yellow, there is too much humidity, not only in the oil, there is too much humidity in your refrigeration system.
Yeah. So you can't really tell whether the moisture is here or there, but it's in the system.
It's in the system, correct.
Yeah.
It's in the system.
Graham Hand is asking, can we tell if the oil separator is full of oil? If it is a small capacity oil separator, 10.900 series, for example, can we tell if it's full of oil?
I'm not aware about the details of that series now, but I'm just trying to imagine a small oil separator, which usually has no sight glass, no nothing. And then to know whether it's full or not, I wouldn't know how to see that.
No, I mean, the only thing that I would say is that if you have an oil separator on a system and you are not maintaining oil in your compressor and it's disappearing, then I would question whether the flow in the oil separator is actually working or not. That would be the only sort of way to see whether it's actually doing its job, I guess. Yeah, a difficult one.
Yeah. Omar Henry is asking, what is the purpose of the oil differential check valve?
Oil differential check valve.
I guess he's saying the check valve in the line that feeds the crankcase. I would presume, and that is obviously to ensure that we only get flow in the right direction. Because if you've got your oil separator at discharge pressure and your crankcase at crankcase pressure, suction pressure, you only want that pressure to go one way. And when we lift the flow in the oil separator, it's basically going high to low. It's good practice, let's say that.
And he's got a follow-up question. Can this valve cause oil pressure loss within the rack system?
I would say only if the valve is not doing what it should be doing. Apart from that, no, I can't think of anything.
Yeah, because you don't have. I mean, if you extremely undersize that valve, but you probably don't get valves that small to push so much oil through that valve that you have a high pressure drop in that valve, that would possibly do that. But I mean, then you need a hell of a lot of oil flowing through that valve, right?
Yeah, exactly.
Fabian Moff is asking, what type of refrigerant is used for filling when it's empty?
I'm not sure what he means by that. Jens, Fabian, maybe you can retype the question, or so maybe what you're talking about is what type of oil should we fill the oil separator with, and that would be the same as the oil in the compressor crankcase. And as we said, check that from the data plate, but a little bit unclear if that's what you mean or you actually mean refrigerant, because then the refrigerant choice depends on the application and the components within our refrigeration system.
See, we are closing in on the end now. Maybe we should just give Fabian a chance to follow up on this question. If our moderator would.
I mean, what I would like to say, not on that question, but in general, thanks a lot for all these questions. I mean, that was pretty good. That we seem to have some interest here. So good questions. It was really good to talk about all that, to see all these questions. And I don't know whether there are still some open questions. And if yes, I guess we have them and can follow up later on offline.
Yeah, we will. Yes, there was a follow-up, but Fabian, forgive us, but we will need to answer that afterwards. Please come back to wherever it is that you are watching this live stream, and then we will, in a few days, have the remaining questions answered in writing. So please come back and see what the answers may be on those questions that we haven't answered live here. I would also say thank you so much for attending, and I'm pretty excited about the number of people actually participating in this, and especially all the questions. Like we said last time, it's the questions we live off. So please feel free to get back to us next time we have a live stream session. When exactly that'll be, I am not entirely sure, but it will be within a couple of months, I guess we should say. Thank you so much. John, would you like to say something before we close?
I can only mirror what you've said, Jens, and Jörg said previously. Thank you for taking the time to listen to us and ask us the questions. The questions are the food that we live off, that has been said before. What I'd really like to know is what other topics would you like us to discuss during these live streams? Because it's good to do these things, but we want to do topics that are useful and people are interested in within the world of refrigeration. So in the on the platform that you're in, please make comment if other topics that you would like us to cover in the future. That would be fantastic. But apart from that, thank you ever so much for listening to us.
Yeah, thank you so much, and have a nice rest of the day, evening, wherever you are. Thank you so much.
Okay.
Thanks, everybody.
Cheers.
Bye-bye.
Bye-bye.